So welcome everyone. Welcome. Yeah, let us know you're there. Fantastic. I hope you're excited for this topic. It's gonna be a great intro to DevSecOps with DevSecOps Reference Design with the wonderful Mr. Nic Chaillan and Mr. Kyle Fox. So without further ado, I'm going to turn it over to you two.
Hey everybody, good morning. This is Nic Chaillan. Thanks so much for joining us. We're so excited to be able to share with you today a little bit about the DoD DevSecOps Reference Design. I'm joined today with Kyle Fox, who just left the government to start at a company called SOSi, where he just became the CTO. Over to you, Kyle, to introduce yourself.
Hi, no, you covered it, Nick. So glad to be here. Over to you.
Yeah, we're so excited to have you. You know, you've done a great job at your time in the Air Force, where you became the first chief software engineer, and we kind of pushed this continuous ATO mindset into the weapon systems, and you've done a great job on the nuclear side. And you know, if anyone had doubt that they can do DevSecOps, obviously looking at what you achieved on the nuclear side should really tell them that everything is possible. I would argue if you can do it on nuclear stuff, you can probably do it on everything else on the planet. So that's going to be an interesting discussion today with you to first go around the block a little bit on DevSecOps and the continuous ATO process, and giving a little bit of introduction on what DevSecOps, the DevSecOps reference design is about. And then, you know, Kyle is going to take us through an entire journey of the key pieces of the reference design and why it matters, and what does that get you, right, in terms of tangible outcome, particularly for government teams and contractors supporting the government. So, of course, we'll take questions live throughout. So if you have questions, go to the Q&A box over here, and we'll be able to help you there. So just to give you maybe a quick rundown on the continuous ATO process. Of course, you already know how painful the traditional ATO process is. You know the average time frame of those, and it's obviously pretty painful. Not to mention stuck in time and often completely wrong. I remember assessing and looking at the ATOs of many of the Air Force programs to find about 95% were outdated when it came just to basic port and protocol and ingress egress information. So let alone, you know, deeper dives on the system itself. So obviously that doesn't work. That doesn't get you where you want to be in terms of being able to move at a pace of relevance. And so we came up with this concept of a continuous ATO first ACASA run, which went kind of a little bit sideways, I would say, without a lot of structure. And so Lauren, the Air Force CIO, and Danny Holzman, the authorizing official for the DevSecOps and the cloud teams, came up alongside myself with this three-pillar approach of the continuous ATO with the platform, the DevSecOps process, and the team. And of course, you have two teams, the team that runs the platform and the team that builds software using the platform. And I think it's important to separate the factory team that build the factory itself and the team that actually builds software. And let's not forget, that's why we're here, to build actual tangible outcomes and not to play with fancy tools. I think some people tend to forget that. So that kind of led us to really defining what are the key pieces of these different pillars. And just to give you a quick rundown there, as you can see here, we have the platform first. And of course, for people using platform one, they get all these capabilities day one, which is pretty amazing. But, you know, of course, we also designed it to be agnostic, and so people could build their own factory as well. And so that's why we created the reference design, to help you understand what are the key pieces to be able to come to a state of meeting the DoD Enterprise DevSecOps Reference Design MVP requirements, minimum viable product, or minimum viable platform, I guess we could call it. And that gives you the really minimum entry to be able to continuously release software in production and meet the DoD requirements. So as you can see, we have hardened containers. We have, of course, an existing environment in terms of the hosting infrastructure. Could be a cloud provider already accredited, could be a weapon system, could be an edge mechanism like Amazon Snowball or Azure Stacks. And you'll see, of course, we have the cyber stack here with the continuous monitoring tools, with the what we call the SOSi container security stack. We'll talk about that today. Then you see the process, and that's where also, of course, we have this feedback loop, right? And the gates in the pipeline to be able to decide whether or not you're passing the gates. And that's where you're supposed to be engaging with your authorizing official to be able to decide what are the threshold of these gates. We have three main gates, right? We have of course, the change management gates, the testing gates, and the cyber gates. The change management gates, you can think of it as how many set of eyes do you need on code changes to approve a change. It could be 2, 3, 4, 5 people, depending on the criticality of the change. So that gives you kind of that GitOps mindset of everything is approved in code, everything is code, no drift between development and production, like we talked about in the previous session with Brian Finster and Rob. And that gets you kind of this immutable state, right? So of course, ensuring that it's never just one person, so you're not at a state of danger when it comes to insider threat. And then we have two other gates, right? The testing gates with unit testing, integration testing, end-to-end testing, and we talk about test-driven development and baked-in testing before you even write code. So that's another key piece. And the last piece is the cyber gates. Of course, you have the basics of the world with the static dynamic code analysis, scanning and findings, and CV scanning and container scanning security. And that kind of gives you, and you define with your AAO the threshold of these gates. So you could say, hey, no critical, highs can be in production up to 5 days after a patch, and then they have to be fixed, or whatever the kind of the time frame and the threshold is. Iron Bank created their own kind of numbers there in terms of thresholds, but every team could potentially, based on the risk of the risk acceptance of that authorizing official, can define those risks. So that's kind of the three gates. And of course, you have the continuous monitoring aspect, right? That's where we bring the Cycle container security stack and the behavior prevention stack. We're not going to have the ability to go over all this, but in 2 days, you're going to be on the Cloud Native Town Gather world, and you're going to find a lot of videos there free to use from Learn with Nic. And there's a video on Continuous ATO where we do a deep dive on all the key pieces of zero trust, moving target defense, and of course the continuous monitoring behavior process as well. The last gate is the team, right? So the team that runs the platform, the team that use the platform to build software, which is really, what we're here to do. And, of course, training, and that's why we create all this content. That's why we want to help raise awareness and break silos and shift people left to be able to be part of this DevSecOps culture and remove the walls between dev, security, and ops. And so that's been obviously so important. And when it comes to authorizing the team, of course, you have different pieces there. To answer Sean's question on the Q&A box, we have a piece of course, looking at background checks and clearances and all the normal stuff. But then you also have a piece of training and validation of training. So there's some different training that people have to do and go through to be able to meet the requirement. And each team can decide what that looks like from training specific to being able to run the platform itself. Whether it's Big Bang or Party Bus. But then we also had a training for teams consuming the factory and making sure that people are not trying to bypass or cheat the gates and try to bypass the rules. Obviously, that wouldn't be the right intent and would create a lot of issues. So I think it's all about training and deciding what kind of learning we have to do. And, we used to give an hour a day to our people to learn at Platform One. So last slide before I give the hand to Cal. As a reminder, we designed all this reference design to be cloud agnostic, and that's so important, right? When you're building capabilities in DoD, you're going to end up building capabilities on weapons, and obviously you're not going to see cloud service provider capabilities on weapons anytime soon, and so you need to be able to run software anywhere at the edge, gap disconnected. So take a look at what Defense Unicorn has been able to do with Zoff, of course, but then here you see also how we decouple the infrastructure layer with whether it's Cloud One on a cloud provider or Amazon Azure, Google, whatever, all the way to C2S, SC2S, fences for SAP, but of course Azure Stack, Amazon Snowballs, just vSphere, doesn't really matter. We put Cubase on top with 5 different distributions of Cubase. Supported, and then we have the CI/CD pipeline on top, completely containerized, fully GitOps enabled, full ability to replicate the stack with a push button instantiation. And then we have the service mesh on top, using Istio to be able to bring zero trust and the enforcement of the policy enforcement point to bring that baked-in security. And by the way, all these layers now check about 90% of the NIST 800-53 controls. So only 5% is left at the application layer. The rest is mostly inherited through the controls brought by the platform and the infrastructure that you use. So that really enables you to decouple and deploy the stack anywhere. And you see on the left side the continuous monitoring stack that really is designed to monitor the entire stack from the infrastructure to the platform to the application layer, gets the logs and telemetry and the behavior prevention mechanism to prevent lateral movement of malicious actor, and of course using zero trust to be able to reduce the attack surface as well. So now with Cal, we're going to take a look at the different stages and what kind of a process do you have to think about when you start thinking of a CI/CD pipeline, and what are the different ingredients to be able to raise to the maturity level to be able to say that you are complying with the DoD Enterprise Reference Design?
Yeah, exactly. So great background, Nick. I just want to hit on a couple of things really quick before we dig into the reference architecture. So first, I want to point out that we are doing this for real. Like the Air Force is operating with DevSecOps, deploying at least to lab environments and soon to operational weapon systems across all security levels. We just came off this Sentinel program, which is one of the largest software programs that's in the works right now in DoD. It's an ICBM modernization program. And we were very successful in incorporating this model. This first reference design that we'll talk about was sort of code developed as we were building the early days of Sentinel program. And we were able to show that this DevSecOps approach, declarative infrastructure, GitOps as a mindset, not just for software teams, by the way, but also hardware teams and our system engineering teams, is imperative for the way that we fundamentally executed the program. And so if anybody ever pushes back on, hey, this is something that's too difficult, it's too new, it's not ready for really important systems, please send me a note and we'll connect you with folks over there, because we're absolutely doing this as an essential part of the nuclear mission. Okay, next chart. Okay, so this is really going to be a deep dive on the first reference architecture. This one focuses on the one that Nick and I built together with a whole bunch of folks, DCIO, et cetera, that contributed to this initial architecture. There are additional architectures. So I saw there was already a reference link in the chat. You'll see one at the end of the brief as well. At the DoD CIO, there's a library page on there, and they describe kind of what a reference architecture is. There's a DevOps playbook. There's descriptions talk about how to form new reference architectures. The idea of these reference architectures holistically is a way so that you don't have to reinvent the wheel, right? It's very, very painful to start from scratch and really silly when we have these agreements in place with the DoD CIO, the service CIOs, and many mission AOs that are executing, this technology based on these techniques already in the real world. So by using one of these reference designs, you're taking advantage of all that pedigree. And again, you can lean on that nuclear mission, like I mentioned before. We are leveraging the CNCF Kubernetes framework, the first one. So it is very suitable for any sort of mission, any sort of requirement. Okay, next chart. Okay, how do ref designs work? So you'll see in the document on DoD CIO's website, and I'll go in detail kind of what each of these components are, but the way to read this chart is there's a series of elements of the way that we build software intensive systems today on the left. The reference architecture comes in with the middle of the chart where you see these interconnects. Those are the opinionated portion of the reference design that you're talking about. And so we'll kind of talk briefly through each of these. I'll combine the first two. But the opinionation helps you at least gel a little bit on, what is this model of mission-based risk acceptance that you're building between your program, your mission AO, and ultimately the service and DoD CIO components. So it's giving you something to build off of, and then that consistency. So It's not just a software factory, right? But it is actually a delivery of real world capability, which includes the whole gamut from software development, integration, test, certification, and all the underpinnings of that as well, helping the program to think through how we think about end-to-end service delivery. So the reference design doesn't fix all of that for you, but it gets the program in that mindset of moving to continuous delivery for all stakeholders in that delivery chain. Okay, next chart. Okay, one of the key aspects of this Kubernetes reference design, the CNCF Kubernetes design, is this concept of a service mesh. And what this service mesh lets you do is it takes your normal operating cluster and it provides a way to monitor and kind of curate the traffic that's interacting with that cluster and ultimately the pods inside of that cluster. It lets you do things like east-west traffic management, starting to build things like very granular access control via admission controllers. The service mesh is a way to provide certain guarantees inside of your pods. You'll see in these reference designs, as you dig through it, there's a table of required elements to be fully compliant. Most of the boxes on this chart are some of those required elements. So like I mentioned, because it lets you really have fine-grained interaction with pods, it helps you with policy enforcement, very, very granular level. So again, the power here is that as a team is starting to do DevOps or maybe scaling your DevOps approach, DevSecOps approach inside of your workloads, this gives you something to build off of. There's IAC and CAC out there. Platform One is a good example that helps you get a kind of like a good bootstrap to be able to do all of these different elements called out on this screen. As you look through the reference design, you'll also see some callouts for things that are optional. So logging, for example, logging itself is something, of course, that is required, but advanced visualization of the logs is something that is a best practice, but not required from your MVP. So, please read through it. Everything in the guide is meant to be an MVP of having a very secure, defensible system that is scalable to meet future requirements in a graceful way. And then there's these stretch goals or optional requirements that helps your team really turn into that modern powerhouse. Okay, next chart. Great. Another component of this reference design is digging into this idea of a certified Kubernetes layer. And let me just poke on a couple of things with this. So first, zooming out a bit, is this concept of a shared responsibility model. And I know this is touched on a few of the intro talks, but I just want to take a second here because it is a pretty different relationship when a team moves into a DevSecOps environment where you're leveraging a platform that's been built by others, taking advantage of policy that was written by yet others. It means that you're moving into this world where you're not starting from scratch every single time you start something. It's incredibly powerful, but nearly all of your stakeholders are used to operating in that environment where every time they see an ATO, it's an ATO that is completely from scratch and one-off. So again, the department in a big way is moving away from that model and instead having these ways of starting points that teams can take advantage of. They don't have to reaccomplish all that work, credibility, et cetera, to reach that starting point and instead be able to focus just on their mission requirements. Okay, so now in the shared responsibility model, similar story. Once you look at the hosting requirements, which again, you can read out in the reference design, it's pretty lightweight. We do really try to harp on being careful with going with any single vendor and not locking yourself into one vendor. The vendors themselves, the CSPs that are out there, will usually advise teams pretty strongly on this as well. Use techniques like Terraform to abstract yourself out instead of doing direct API calls. That's good for everybody because now you're portable so that anytime that an offerer is more exciting, you're able to move your workload to them. So again, it's good for government, it's good for designers and builders, and it's good for CSPs to actually be portable. Moving up into that container orchestration layer, for many workloads, this is where we start to see responsibility move into the program. So you have a couple of choices here as a program. You can operate almost as a type of a SaaS model, and I'll be careful with the way that I use that word. You could use something that's like party bus, right? Platform one party bus, where you're taking advantage of a platform that you're essentially subscribing to a software factory and then building mission apps on top of it. And it also comes with some deployment help. That means that you're leaning on the body of evidence and that buildup of credibility from platform one at the container orchestration layer down, e.g. you're not having to start over with that. For other workloads, like what we did with Sentinel, because it's large, it's cyber physical, it has a huge range of risk areas in the program, from some of the most sensitive code in the arsenal. We're talking about semi-autonomous nuclear weapons, e.g. nukes in Nebraska. Inside the workload, we also have time and accounting and info display systems, and those are very much not equal. So when you have this huge range of consequence models like that, it's valuable for teams to staff up the ability to maintain your own orchestration layer. And again, the reference design does accommodate that. It turns into an agreement between your authorizing AO for who's managing your platform and through the mission AO. Another pro tip for programs very early on, this is something that was really a key point for us in Sentinel in particular, was to make sure that you really engage with all of your authorizing officials who may have a say. And it's not just cyber. You need to be pulling in your system safety, your nuclear surety, if applicable for you, any sort of airworthiness components. Think about anyone that has an interest in the outcome of your system. Those are the folks that need to be engaged with making these mission-based risk decisions. And again, you have to think about, what is your model? If you're more of a website, then you can take advantage of some of these more platform as a service-based solutions. If instead you're a little bit more complex than that, you need custom configuration, then you would use a product like Platform One's Big Bang over Party Bus. And there's other models as well. Okay, next chart. Great. And this was the last main chart actually in in this deck. So I want to just touch on really quickly what the CNAP service is, and then I wanted to open it up for discussion with Nic and I on the line here. So another key part of the reference design, and it's really a bit bigger than the reference design itself, is this idea of a cloud native access point. And so why does this matter, right? One of the real challenges is, okay, cool, we can do DevSecOps well inside of a well understood enclave. We talked about the CSP interaction before. We've talked about the platform just a second ago in this talk, but it doesn't mean anything if that is not connected to your developers, to your various authorization stakeholders, and ultimately that end item weapon system. Because remember, our goal here is not to do CD really fast to a lab environment, but to do CD all the way into the pointy end of the mission, so that it actually means something to our warfighters. And when there's any sort of conflict or otherwise, we're able to operate at that true speed of relevancy, not just the speed of the lab. So CNAP is a way for us to very much simplify the interaction between where our endpoints are, where the data and development takes place, and where the mission is being executed. This is described in both the reference design, and there's actually a separate document that talks about CNAP. So by using this service, it simplifies access into cloud environments. You'll see that CNAP is available not just at the unclassified levels, but also at IL6 as well. It provides you a way to manage identity. It provides you just the start of doing some really cool things, like keeping all of your data in the cloud and instead using virtual desktops and things like that, so that your end clients can be thin or zero clients, which can be pretty impactful for very high assurance missions. Okay, let's go one more chart, Nic. Okay, so how do you get smart and really do this? So at the DoD CIO sites, they have this library page that digs into all of this material. There's other great resources on there too. The Zero Trust placemat strategy as well is on there. You'll see this DevSecOps playbook is on there. The reference design is on there. The various other reference designs, which have things like Azure DevOps model, is another reference design that's described on there. There's also links from that page to working groups and like-minded folks. If you have questions, how to keep going. Also recommend that folks look at that repository. I mentioned before that there is this IAC CAC out there via Platform One. That's an awesome way to get started with this again. So you're not having to build from scratch, and you can take on really battle-tested IAC and CAC that's serving nuclear mission. And then a shout out for training as well. So software.af.mil. I know, Nick, you're very familiar with that site. Those training resources are great out there. You'll see a familiar face taking some of those classes. And then also, Nick, on your service, you want to give a quick discussion about what that is?
Yeah, sure, absolutely. Yeah, well, I think a lot of people realize how difficult it is to keep up and move at a pace of relevance and keep track with, all these open source tools. And that's why we created this Cloud Native Town Gather universe you're going to be trying on Thursday. And hopefully you can give us some feedback on what to improve. We're partnering with so many companies for free, giving them access to share the content and release information about their next features and releases. And we created Learn with Nic to kind of bring new content every week, new events, new discussions. Actually, today we're going to have Greg Tuhill on the show to talk about the future of cyber. Next week we have Rob Spalding to talk about World War III and what's happening with China and Russia. So it's always very interesting to be able to share and collaborate. So we created all these rooms and these environments to be able to create this collaborative experience and try to bring people together. We have 7 nations, multiple telcos, banks, healthcare companies, about 5,000 subscribers now to be able to come and share and learn together. And if you want to have different topics, let us know. But if you go on cloudnative.town, you're going to be able to see all the videos we talk about today with deep dive on pretty much every topic we just talked about. And if you see stuff missing and you want to do a deeper dive, we release new video every week. So let us know if you're missing something that you don't really understand, or you want to do a deeper dive on one of the topics.
That's great.
I guess we answered quite a few questions on the chat here. Well, you did the same, and I did the same when you were briefing. So I guess the question is there more questions for anyone from anyone in the audience? I think the bulk of the question I was taking was about why Cubase and why not supporting other options, including just VMs or native options. We did a video on why Cubase is a must, and even if you think you don't need it, by the way. And it's way more than just orchestration, right? It's also about the baked-in security and injection of visibility and centralized logging and telemetry and enforcement that we get, including the zero trust enforcement, and not to forget about the importance of the fact that you cannot federate zero trust. So if the minute you start bringing different stacks, the minute you have a different policy enforcement control plane and data plane, and that creates massive issues down the road the more you grow. And so you can get away with it with small teams, and that's okay. But if you start thinking as a department, first of the Air Force Space Force, but then of the DoD with JADC2, and you're going to start connecting weapons and do this Internet of Things of capabilities, you're going to realize pretty quick that it's all dependent on zero trust. And to get there, you need short-lived identities. You need to be able to define access control all the way down to the data fabric layer. We have a video on the Cloud Native Town about what is data centricity and how we label data down to the cell level, and how do you enforce it both on the user side and the data side, and how do you delegate the access control down to the data owner to avoid bottlenecks and bloated nonsense. So there's a lot of components there, and you're going to realize pretty quick when you start bringing all these capabilities, particularly with GitOps and CD and the automation of the stack, and particularly on the continuous monitoring side, that if you have snowflakes and different teams doing different things, pretty rapidly it's going to be pretty difficult for teams to be able to keep up and have the same enforcement and the same cybersecurity stack and the same visibility across the entire enterprise. And that's why we believe in a cloud agnostic capability that would be able to run anywhere instead of using specific cloud service provider, PaaS or SaaS capabilities. And that's why we designed it to be agnostic. So if people have more questions, I'm happy to dig into that. And make sure you use the Q&A box if it's a question instead of the chat, so we can keep track of the questions.
For sure. Hey, Nick, real quick on the why Kubernetes conversation. So just some context again from the new commission. There are definitely some environments that are hard real time, right? That Kubernetes is not ready right now. But that doesn't prevent any team from doing CD or using Kubernetes as a way to manage everything else, but that like thin layer of the mission set. And so that's what we did on Sentinel. We absolutely DevSecOps, even for our deadline critical hard real-time environments, but all of the build, test, cert, tear it apart and break it virtual environments, those are absolutely based in Kubernetes.
Yeah, so we have a question. That's a great point, right? And we have a question from Evan here from the Navy, asking about how do we authorize the team when some of the team are not government and they're obviously either primes or part of a contractor. Well, it's the same. We don't really think of badge cutter or where the people are coming from. We have the same requirements regardless, and we share that requirement with the prime on the contract. So usually that's the most important piece to do, is to make sure that if there's training requirements or skills or any kind of clearance requirement or whatever, of course you're gonna have that in the contract. And usually it's pretty common to have clearance stuff, obviously, but people forget about training and making sure we empower people to learn. Like I said, giving an hour a day to people to catch up and then keep up is probably a must if you want to make sure your team doesn't become obsolete by the time you're done typing on this keyboard today. So you want to invest in people, and people struggle with investing in contractors somehow. We're fine paying them a fortune in FTEs, but we still push back when it comes to learning. We feel like, oh, they should be learning elsewhere or off time of the contract because we're paying them to already know things. Well, that's not that simple, right? At the same time, you want to retain talent and people so you don't have a massive turnover. So it's pretty conflicting, right? If you're saying you want to keep people, you also want to invest in them so you don't just get stuck with people that are getting obsolete by the time you're paying them and the more time goes by. So I think investing in people and decoupling that is so important. Am I missing anything, Kyle, on this?
I would also add, just like if you have completely separate teams and they're not talking to each other in hallways, things like that, you've got a culture problem. So it's important that on all these platforms that you have joint buy-in between your vendor, their subs, and the PMO. And I recommend that you basically build at least small Pathfinder teams that are in a badgeless environment. It is scary at first, particularly with concerns over, oh my goodness, you're going to exceed scope and things like that. But again, a Nuke Weapons Center is a good resource for you if you have contracting officers that are concerned about it, or on the opposite side, if you have PMOs that are a little nervous about this. It's been demonstrated to work where we brought in Northrop, we co-built the platform together, partnered directly with Platform One, and Northrop actually requested the service. It wasn't something the government forced upon them, because we built together over time. We learned how to use it. We built that trust environment that's critical for doing DevOps for real.
Very good. So Rob is asking, can you discuss the progress with DevSecOps and DTNE? And can you also discuss the limitation or lack of progress in some areas of the program or programs? Do you want to take that one, or you want me to do it?
I'll start. So DOTNE actually is making some pretty good strides over the past few years into this environment. It is still something that is frontier, right? I would classify DoD as getting pretty good at doing DevSecOps to a lab, less so frontier for doing it to the actual pointy end weapon systems. And DOTNE is going to be a key partner for that. There is a reference playbook, a DOTNE playbook that's in draft. And they're hoping to publish this year in the spring. At least they were this summer when I was back in Air Force. And my recommendation is that anytime you're engaging with any sort of tester, DOTNE, or you have like a combined test force, make sure that you bring those folks in, your testers, early into this DevSecOps environment, and really do everything you can to dispel the myth that this is a software-only thing. This is about delivering capability. It's not just a bunch of software coders hanging out in closets with RGB keyboards. Like, this is how the mission will be executed. Anything else, Nick?
No, yeah, shifting left, fast, and don't think of them as external team members. Ideally, if they become a bottleneck, anything that's a bottleneck should be considered part of your team, and that's where you want to focus your time anyway. So making sure they're trained and spend the time to really have them part of the team, and even maybe do sessions of sprints with those guys to create some automated not just unit testing, because that's pretty basic, but more importantly, end-to-end and integration tests as well. All right, there's a question from Don saying he's been using open source as late as the 80s, and there was always the problem of upstream changes, either breaking or introducing cyber issues. Given the increased pressure of leveraging open source, I don't know if it's a pressure, but given the increased pressure of leveraging open source, how is the DoD planning to integrate these projects short of forking them? Forking is such a bad term. I hope never, ever again anyone on the planet ends up forking an open source project. It's obviously a very bad practice unless the project is dead, of course. But when it comes to, I guess, the pressure of using open source, of course, it's a pressure driven, I think, by common sense, so we can save time and money and be more efficient. But I think the key aspect is to pick the right project. Ideally, you want to invest and bet on open source projects that have pretty significant automated testing of their capabilities, so you can demonstrate, by upgrading the bits that you're not breaking things. And so, of course, you can add your tests on top of those tests, but you want to certainly inherit a lot of existing testing from that open source project, so you can demonstrate that first, the open source capability is still behaving the way it's supposed to behave. So, of course, looking at their test coverage and maturity in testing is essential. And then you want to create your own tests on top of it to demonstrate that how you use it is not breaking as well. So I think it's like any kind of software, wherever it's coming from, whether it's one of your team member making a change or an open source community upstream making a change, I don't think it matters, right? At the end of the day, your test coverage and your maturity in testing should be what helps you ensure that you're not breaking things in production. What about, what did I miss, Cal?
Well, again, I'm just going to harp on, we're absolutely embracing open source software, even in the nuclear mission. So I don't view it as something that is inherently ingesting crazy vulnerabilities and weapon systems. It's just software. So like any software or capability for that matter, it's important that you understand what it is, what it's doing, and then does it meet that mission objective that you're trying to achieve. There's a lot of ways that you can help bolster these projects. There's policy things you can do. There's things that we're doing inside of Istio, like restarting the pods every 4 hours, right? There's things that you can add on that aren't just avoid open source. And the other fun thing that we're really starting to see now that SBOM is getting out there in a big way, it turns out that a lot of these vendors that give you a shrink wrap product that say it's secure are really just based on a bunch of open source stuff that has questionable investment in its security.
There we go. So don't forget, if you put the question in the chat, it's harder for us to find it. So make sure you use the Q&A box. But I found a couple on the chat here. So what would you recommend, Cal, for teams that still have to support VMs for apps like SharePoint? I can give you my answer, but I'll let you go first.
Yeah, so some of this stuff, I would love to just burn it all down and move it cloud native. But it's not always possible, right? And I just came from this. In fact, at the group I'm in right now, right, we've got a bunch of contracts with Army, and it's exciting to do network modernization for them in a big way. And they have these sometimes databases, and Air Forces, any of the services are just as kind of in the same boat here. They have data sets that could be 30 years old, right, 40 years old. And so it's kind of a strangler pattern type answer, right? Understand what that mission outcome that you need, understand the services that are being used to provide that thing. And then if it's truly a virtualization type requirement, work with the vendor of that software, pressure them, reach out to others using the platform to pressure them to break it up into something that's more cloud native friendly. Last thing I'll end with is that VMs can still be managed with GetOps. You can still use service mesh on it. You can protect east-west traffic. There's a lot of security things that you can do to VMs that are outside of the traditional way of deployment. Over to you, Nick. What did I miss?
Yeah, and I think it's important to separate commercial off-the-shelf products from VMs that are GOTS or custom code, right? I think when you go off the shelf, you inherit whatever product you pick, and you have that stinking time kind of aspect. But at the end of the day, I think what's important to realize is that those teams will have to modernize their stack, or they will go out of business, and you will be stuck with some type of ugly GOTS to maintain for years to come. So, I think it's important to work with a team, and that's what I did a lot in the Air Force, and proactively reach out to a lot of these companies to tell them, hey, you need to start thinking of modernizing your architecture and move to a containerized mindset. And I think you're going to find that they are probably already working it or trying to build the capabilities together. So in the SharePoint example, of course, there's a cloud service now, but I think you're going to find that another shelf stack is a little bit different, right? So that's my first aspect. The second aspect, like Kyle said, you can totally still run a service mesh and all these things. You lose a little bit of enforcement aspect, but you can still use, right, all the concept of GitOps and automation infrastructure as code, configuration as code, right? So do that at the very least. There was another question on the chat about, what is a top programming language and the top CI/CD tool preferred by DoD for DevSecOps engineers. That's, languages, you're going to find a little bit of everything from Go to Rust. I think Rust is going to be very exciting, particularly for embedded systems. But you're going to find a lot of everything from Java to Go to, C, C++, whatever, right? Use the best tool to get the job done. It doesn't really matter. Of course, you want to minimize cyber risks and issues and look at plugins and dependencies and things like that. But then when it comes to CI/CD, there's a lot of different adoption. Of course, you're going to see a massive footprint of GitLab CI, Flux, Argo, Harness is coming now as well. You have Cloudbees. I think the issue you're going to find is many of these tools, since you need to have a Git repo, and most of us need to use, something on premise on the container instead of using GitLab.com or GitHub.com. As a SaaS service, which I certainly don't recommend using, by the way, because of the multi-tenancy risk for teams, unless it's an open source project. And so then you need to buy Git. And so if you need to buy Git, it's kind of tough to say, I'm going to buy Git and buy Git is something like GitLab, and then now use a CI piece and buy another product to buy for the CI component. So a lot of people would end up, with GitLab CI for the CI, but then it's up to you to decide also, can you augment it? Right, there's different products out there that can add security stack on top. You have CD pieces now, of course, with Algo and Flux and different companies like Weaveworks and Harness and all these guys. So I think that the key is to have a stack that you can maintain and bet on, and try to avoid getting too locked in on that. And we've seen it with Platform One when we had to swap between Algo to Flux. It's a pretty significant swap. So you need to pay attention to the decisions you're making, because that's going to create a pretty massive, technology debt if you pick the wrong bet. What did I miss, Kyle?
I'm just echoing some highlights there. Get to know your customer. You'll see there's a whole lot of old stuff out there because like a lot of things that we are doing right now in DoD and broader government, can be multi-decades old on average. So work with your customer, understand where they are. And it doesn't really matter overall. Like if you're C-based, you're Rust-based, it doesn't really matter. I mean, you can have crappy code in any language. So understand what you're inheriting and then work with your teams to make sure you're meeting those mission outcomes. It could be investing in test. It could be, oh my goodness, this is so much trouble with this repository. We just need to reboot it and start over. But sometimes that's the right decision.
Yeah, I think we have a couple of minutes with one last question, and there's a good one on the strangling pattern, and we have a video on the strangling pattern too, by the way, so check it out. But the question is, if we are strangling all code, do you recommend starting with something complicated that hits everything or something small? What do you think, Kyle?
So definitely know your customer on this, but it's always nice to start with something small, change the light bulb example that you can show immediate value, and then aggressively, continuously deliver value. But it may not always be the right choice. Sometimes when you dig into it and you realize they're going to spend 100x what it would take just to do something brand new. Sometimes it is worth doing that big gutsy decision to just reboot it, burn it down, and do a new start effort. Nic?
Yeah, I think it's important to cut it, right? Of course, any change in the strangling pattern has to be small, 2-week sprints, right? The question now is, do you focus on something simple or something meaningful? There's two different aspects there. For me, it's always important to pick a very meaningful feature, or at least an aspect of the business of the organization that's important to the organization. So keep that in mind. You don't want to pick nice to have little detail thing. You want to pick, make a change on a piece of the using domain-driven design and cutting it. And we have all this in the video to explain how to cut your monolith into domains and then, sprints and how to prioritize also based on the user demands, right? You don't just wake up and pick it, by the way. That should be driven by the end user asking, monetization features. And when you rewrite software, you don't just rewrite software, you augment it with new features while rewriting it into microservices. So you're not stuck in time for years rewriting the same crap, right? So keep that in mind and pick something meaningful. So when we did it, in fact, when you look at what we've done with Kubernetes on Jets, we pick an F-16. I could have picked some business system out there. We wanted to demonstrate it's meaningful for the mission of the DoD, and it had to be a weapon. So we picked F-16, which was not the easiest example we could have picked, but it's also, showing that if that's possible, then everything is possible. And so then you open the door to success, right? So.
Any other questions? We got time for one more question.
And there's one more here, I guess. All right. How can you validate software from continuous delivery if the environment it is going to operate cannot be modeled, specifically sonar operation in the ocean? You want to take that one or I take it?
So I'll take a crack at it. We'll tag team this one. So I think there's a few pieces to the question. So it depends on what you really mean here by validating. So it doesn't necessarily mean that you need to build something that is like formally proven, right? That you go down and you can show that, hey, these molecule is moving by this much energy level because of X. It doesn't need to go to that level of specificity necessarily. I think you just, again, try to break it down to those very simple ground truths. What mission outcomes must you achieve? What risk can your platform truly accommodate? And then once you establish those risk boundaries, CATO style, how do you take advantage of frequent deployments so that you can learn and do better on that end platform? Nic, any other?
Yeah, I think anything can be modeled. I think it's a matter of cost and complexity. Obviously, sometimes it's not worth it. And you don't need everything to be modeled to demonstrate software is going to behave the way you think it's going to behave. And look, perfection is the enemy here, right? You want to get to good enough, right? So my take is model what you can model, assume what you can't, and then learn fast and fail fast. And look, taking 5 years to make a decision is not going to make you learn faster anyway. So I think going to production and really get tangible outcomes and feedback is going to be giving you that learning experience that you need to make decisions. So, that's what to focus on. The rest is, nice to have.